Hi everyone, my name is Michael Offiero. I'm a student in Dr. James Leonard's Geographical Research Methods class, and this is going to be my article review presentation on the recently published Bachmann and Kaiser 2025 article, which is entitled, give me a minute, Investigating Web Mapping's Contribution to Students' Learning of Geographic Thinking. And so I will go through a thorough review of this article, and then at the end, I will elucidate themes from the article with a textbook chapter that was written for um, a, the textbook Approaches to Human Geography by Martin Dodge called Mapping and Geovisualization 10 years earlier in 2015. So these two pieces of writing are far apart, but the 2015 chapter does elucidate the 2025 article. Now, my normal software that I use to record videos has been giving me problems, so I'm using Zoom to videotape this, and I am doing this in the form of a PowerPoint PDF. So I will be uh, doing it in this format, and I very much like this format better. So here we go. Um, so for the introduction and the research question and the hypotheses, the authors of the present study note that with the advent of geospatial technologies and GIS becoming increasingly digital and web-based, there are a lot of studies out there that address this subject, but most of the studies do not address the idea of geography in education, specifically on the concept of interactivity, which the authors themselves, Bachmann and Kaiser, define interactivity as the different ways of presenting information to a user within an interface in response to that user's choices. I'm going to read that again. Interactivity defined by Bachmann and Kaiser, 2025, page 28, is the different ways of presenting information to a user within an interface in response to that user's choices. So let's break this down. And I'm going to do it backwards. So in this study, um, and I'm going to foreshadow a bit, a group of 20 students were given three activities involving web maps. So they had to answer questions based on these web maps. So they made when answering the questions, they made a choice to pick on a button or select something or highlight something. That is a user choice. And then in response to the user choice, the map displays some semblance of information. And that's what makes it interactivity. So the student choosing to select something or highlight something, that's the user choice, that's an interaction. But what makes it an interactivity is the computer responding to the student's action or interaction of highlighting something or clicking something or panning or doing something interactive. But what makes it interactivity is the computer responding. So that's the concept of interactivity. Um, Interactivity has been studied in the literature very much over the last decade, but there are gaps when it comes to geography education. Thus, the authors pose the following research question: how might web mapping contribute to the learning of geographical thinking through interactivity? And previous studies have also pointed out that technical ability or having the knowledge base to do something or not do something as being a hindrance to learning, leading to the following two hypotheses. The technical ability to use online mapping tools does not hinder student learning progress, meaning that if the students struggle in the beginning, it's not going to keep them from learning as they move along. And hypothesis number two is that the interactivity contributes to students' geographical thinking by fostering the mobilization of higher cognitive processes. So the interactivity will actually encourage the students to think critically, and um, it will make their minds more uh, creative in coming up with ways to solve harder and more complex problems. And that's what the authors mean by higher cognitive processes. So, using these different research methods, the authors state that their aim is to illustrate how the use of different types of interactions is not a hindrance to learning, but is in fact likely to contribute to the learning of geographical thinking through map interpretation. And that's from page 29. In other words, the student's comprehension and understanding of the maps will increase as they progress through the activities. And then with the literature review, just really quick, with the development of new, more advanced geospatial activities, teachers, practices, and students' learning and comprehension of geography have and how it is solved geographical problems are evolving over time. That's a basic idea with the advent of the digital world. Field work outside of the desktop is also good for group work and peer learning. However, the emerging theme here is that the development of these technologies doesn't promote learning if mobilization activities for that learning don't occur. And there are also gaps in the literature surrounding geographical technology and education because most research focused on geography is focused on university students, high school students, and those at secondary schools, with little done on elementary schools or teacher education. So, furthermore, none of these studies focus on interactivity, despite how crucial it is in its use with geospatial technologies. So the authors cite Roth from 2013, 13 years ago today, 12 years ago from when the article was published. And he stated that there is a need for further research of the contribution of interactivity to the visualization of geographic information and by implication to knowledge construction. And that's from Bachmann and Kaiser 2025 to page 30. They quote Roth 2013. And that's what they're trying to expand on Roth's research, expand on that idea that Roth presents. And yet it took 12 years to get this going. So for data and methodology, to investigate learning, they developed a map interpretation taxonomy that is based on Bloom's revised taxonomy. Inspired by another study, St. Mark et al. 2017, who used a similar method using mouse tracking and contextualizing their results within the taxonomy. So in this case, the role of interactivity on learning was resolved with the help of a map, and interactivity was recorded by mouse tracking and map events. That's just a map events. Each of these components was then translated into a criterion to assess the student's production and assign a taxonomic score. The four main taxonomic scores that stood out were master cartographic language, obtain information, connect, and problematize. So the authors state that in summary, this taxonomy allows us to analyze the contribution of the interactive cartographic features on a learning achieved according to the mobilization of cognitive processes and knowledge levels. And metacognition was studied separately for feasibility purposes. But basically, what they're saying is the the mobilization of cognitive processes and knowledge levels can be assessed using the ta- taxonomy system, um, because the interactive cartographic features are being pointed out and being converted to those scores, and those scores can be analyzed and through statistical analysis, which I'll get to in a few minutes, and that will tell them if there's a correlation between the interactivity and learning or not through statistical analysis and seeing if it's correlated with the taxonomic system that they developed. So this study took place at a secondary one school in Switzerland with a group of 20 students aged 14 to 15, having been taught geography since elementary school. The students came from varied classes and met several times a week during the spring and fall in a class setting, and it was the first time any students ever used a web map in a classroom setting, so this allowed data to be collected over a period of time. So there was 3 web-based activities where they answered questions using indicators and layers supplied by an online map, with each question on the map being based on a taxonomic score. So each question was linked to a taxonomic score, and that's how the students were evaluated and assigned taxonomic scores based on the scaling system from Bachmann 2020, page 38, which is on the next slide. Surveys were given out after each student to evaluate their metacognitive ability. The web mapping interface used was created specifically for this study, and the teacher came up with the themes for the maps. So there was some subjectivity and bias because it had to be within the context of the curriculum. And there were different types of maps, and histograms and line graphs were included as well. The interactivity and interactions employed can be viewed on a subsequent slide in Table 2, which I'm about to show. So this is what they used. So this is the taxonomic scale. This is score 1, the mastering of the cartographic language. This is score 2, uh, obtain information. This is score 3, connect, and this is score 4, problematize. And then score 5 with the metacognition was separately evaluated. So the questions were tied to a cognitive process. Sorry, my eyes are bad. A cognitive process dimension, a cognitive process dimension on the left and a knowledge dimension on the top. And together, these two produced a taxonomic score somewhere here in the scale for that question and answer. And that's how you got the scores. The criterion for the scores for C1, the student masters cartographic language. C2, the student retrieves relevant information from the map. C3, the student coherently links information from the map. C4, the student problematizes information and relations generalized from map interpretation by mobilizing his or her knowledge in a relevant, incoherent way. And 5, the student identifies his or her difficulties in completing the task and how easy it was. So this was the taxonomic score criteria. So 4 is the best, and 1 was basic. But it was a combination of cognitive process dimension and a knowledge dimension. And then you have this. So remember, here's the interactivity, and remember, so you have certain interactions that the students engage in, which points to a type of interactivity. So, for example, let's say a student highlights something. That's an interaction indicator or interaction for short. And then the computer highlights that in response. That's interaction with data. That's the type of interactivity. If the student puts two maps next to each other, that's juxtaposition, that's interaction, and that's contextual interaction. That's the kind of interactivity. Just to do one more, spatial navigation zoom. Suppose the student zooms in, that's interaction with the data representation as the map will zoom in response to the student's choice to do spatial navigation zoom. So that's what this is, the interaction indicators and the types of interactivity they associate with. All right, data and methodology part 2. This is where it gets complicated. While not typically used with web mapping, the authors utilize mouse tracking as it portrays some fascinating information. They use spatiotemporal clustering, which can illuminate trends or patterns in databases with geographic coordinates, and it was used to process all this data. About 2 million mouse movements and map events were collected, and the spatiotemporal clustering was used to remove noise, and this brought down the final data set to 1 million records of every student's case of interactivity from all three activities. Then a statistical test called a principal component analysis, which is a rigorous statistical procedure that takes extremely large data sets, breaks them down, removes the least important variables, and the most important ones remain with all the information they had maintained, and now correlations between these more important variables can be seen. The authors also did a temporal PCA on all three activities to try and locate at which times and frequencies certain parts of the interface were mobilized. And we'll talk about more about what they found next in the results section. Finally, the last thing the authors did was they held focus groups with the students. A focus group defined by Longhurst and Johnston, 2023, in Chapter 10 of the book Key Methods in Geography by Clifford et al. On page 172, states that a focus group is a group of people, usually between 6 and 12, who meet in an informal setting to talk about a particular topic that has been set by the researcher. These groups are intended to be homogeneous, last 1 to 2 hours, and interaction between group members is encouraged. These groups are essential to gathering the opinions of a large group of people at little expense and quick time periods. They are also important to consider what questions to ask based on the context of the research. And a lot of times these focus groups can add to what is found in statistical analyses, for example, which is what we're going to see in this study. But for this particular study, because of the COVID-19 pandemic and limitations of the school, the researchers could only conduct 4 focus groups, I believe, with 3 to 4 people, and that only lasted 20 minutes each. All right, so now we're going to talk about the results. In terms of interaction, so that parameter, not interactivity, interaction, spatial navigation, which is when you're moving around the map, and display layer attributes, which is when you click on a layer or a part of the layer and it tells you information about the layer, were the most commonly used, which makes sense given that the students had to explore and navigate the map to answer questions and interpret the map data to complete the tasks. And in order to interpret map data, display layer attributes tells you information about the layer which could help you interpret the map. And that also mobilizes cognitive processes as well. In terms of the taxonomic scores, mastery of cartographic language, the C1 score, and information extraction, the C2 score, were the easiest, which actually makes sense given that spatial navigation and display layer attributes were the two highest interactions, especially the display layer attributes, while metacognition, analysis, and problematization were the most difficult. However, consequently, taxonomic scores all increased across the three activities, with the highest increases being seen in the ones that were the most challenging at first. So this affirms the first hypothesis proposed by Bachmann and Kaiser that technical ability does not play a role in being able to learn the material, a negative role. Um, the authors state these results show that the students improve their mobilization of higher cognitive processes during the three activities as suggested by one of our hypotheses. So hypothesis one is confirmed. The uh, PCA revealed that three components, technical ability, investigation and comparison, and synthesis ability, summarized about 78% of the data. And with this analysis, technical ability was representative of 45% of the data, represents an efficacious use of the web mapping interface, adding an additional positive contribution to learning, and its role in projecting interactions and taxonomic scores is demonstrated because it's 45% representative. The PCA factor was then transformed into a variable itself, and bivariate analysis was performed to further examine the statistical significance of the technical ability parameter. The analysis showed a negative trend over time during the activities with an R squared correlation of 0.71 for problematization and 0.52 for connection taxonomic scores, and the others with moderate R squared correlations averaging 0.44. These results partially support the first hypothesis as well. Temporal PCA conveyed that when four specific interactions, spatial navigation, display layer attributes, spatial navigation move, and highlight are mobilized in an intermittent or moderate way, a moderate to significant impact on scores and mobilization of higher cognitive processes is observed. So when these particular interactions were selected during the activities, the students were more subject to use their critical thinking skills to answer the questions and solve problems that were posed by the activities that were in the activities. And together, all of these statistical analyses provide abundant evidence to support the second hypothesis that students um, will think will have more higher and critical thinking skills with the I don't remember the hypothesis off the top of my head, but it was supported. Hypothesis two is supported, and you can see it here in this line graph. Global trade was the first variable, the first activity rather, and see how it's here at the bottom with a higher technical ability being positive, where this means you would need more technical ability to do it, where this is where technical ability is difficult, and going underneath it here, this is where you see that technical ability, the total score is positive. Um, so you can see that as you go back to activities 2 and 3, the influence of technical ability tends to wane with time. So you see that negative correlation, meaning that over time, technical ability becomes less of an influence. As the students mobilize those higher cognitive processes, those higher critical thinking skills. All right, results part 2. So the focus groups conveyed that while students had difficulties with the software in the beginning, by the second activity, they were able to adapt and use it more, once again, supporting the notion that technical ability is not a roadblock to learning. Students said that they liked working with the juxtaposition, highlighting, and displaying attributes, interactions, which lines up with the initial PCA based on which ones were used the most. Another finding is that learning and immobilization were affected by semiological and semiotic features of the graphic representation types, such as how they were displayed, such as having trouble with interpreting some of the maps, even when given line graphs or bar graphs. Students said they preferred choropleth maps, suggesting a visual aesthetic plays a role in interpretation. So what we see here is that the semiological and semiotic features, that's the way that something is displayed, can have an impact on learning as well. The choropleth maps do tend to be easier to read than other types of maps, which is probably why the students liked the choropleth maps better. And it was harder to read certain other maps. Finally, students mentioned using juxtaposition and other strategies, emphasizing their metacognitive ability, which amplified throughout the 3 activities. Summarizing findings from the focus groups, the authors state, it is interesting to note that these focus groups allow us to partially confirm and complement a part of the statistical results regarding our hypothesis evaluation while highlighting additional parameters that contextualize the student's learning, and that is from Bachmann and Kaiser, page 43. All right, discussion and conclusion finally. The results of this study, as demonstrated by increasing taxonomic scores throughout the sequence of activities, show that technical ability is not and this is conversely to previous literature, that technical ability is not a hindrance to learning, and that mobilization of higher cognitive processes, or in other words, the occurrence or an emergence of more critical thinking skills, is apparent with interactivity. The burden of technical ability tends to gradually wane over time while learning increases as those cognitive processes and critical thinking skills are increased. This research adds to the existing body of research that currently exists on geography education in secondary schools using web maps. It is also found that the web map may additionally foster and promote higher cognitive processes. We know that. The authors make 6 suggestions, which can be found on page 43 to 44 in the discussion section. For time's sake, I didn't want to list them all here. This study was unique among others because it is the first study to look at interactivity with web maps among a group of secondary 1 students. Statistical analyses and everything else performed confirmed both hypotheses, specifically the first one, that technical ability is not a stumbling block, and the statistical analyses that the contribution of cartographic interactions in the activities are all related to a combination of all 3 types of interactivity. That was confirmed as well because the students were clicking on all different types of those interactions. So it's a combination of all 3 types of interactivity were involved in those 3 activities, as I demonstrated, and as the analysis demonstrates. The focus groups point to additional factors not caught by the statistical groups, such as trouble interpreting certain graphs, visual aesthetic preferences, and the influence of positive and negative emotions. And then finally, the authors conclude by stating, we are convinced that this type of methodological and theoretical articulation is appropriate and relevant to study the to study the contribution of web mapping and possibly digital tools on students' learning, and that's from Bachmann and Kaiser, page 46. Okay, so we're probably way over time, but I got to keep going anyway. Um, Now we look at the textbook chapter. So, a few things that I want to highlight from the textbook chapter. It's about mapping and geovisualization. In this chapter, Martin Dodge ascertains that true ethical map making takes great technical skill and ability, while Bachmann and Kaiser find that technical skill and ability is not required to interpret a map. So a question to ask is, especially in today's digital world where there's a lot of open source and free data and almost anybody can make a map, what if unethical or untrustworthy maps are created and people have access to them? Does that mean that maps not made truthfully and ethically can be uh, interpreted as such? The untrustworthy maps will give false information, especially in today's modern world with the advent of free, open source, and digital map making capabilities. So I thought that was pretty interesting. Um, and he also elucidates the idea, that he says from the switch from analog media to digital interactivity has many implications, including software and online services, the way geography courses are taught. Bachmann and Kaiser are studying computer based web mapping in an educational setting, so that elucidates Bachmann and Kaiser there. The way field research is done, and the exceptional growth in computer based web mapping, again elucidating the study. Then this is these last two bullet points are the main elucidations. On page 15, Dodge discusses the politics within the map, or the idea that maps are only selective or partial representations of reality. He discloses how some critical scholars believe that this selectivity is political and or serves the interest or interests of some third party. So basically, there's subjectivity in every map. There's a bias that exists. There's a human bias that exists in every map because every map is created by a human. So there's politics within the map. There's a third party interest. In looking at the Bachmann and Kaiser study, it is explained that the maps chosen for the students' view were chosen by the teacher to fit the curriculum of the class. Thus, subjective bias was introduced into the study because the researchers had to abide by the teacher's guidelines and also by the school's guidelines when doing the focus groups. I didn't mention that, but they did have to go by the school's guidelines for the focus groups and a few other aspects of the study. So there was a subjective and human bias there to the subject that the maps were based on. They were economic maps because it was an economics class. So the teacher had a third party interest in making those maps or in having influence in what those maps were about. The last elucidation is the cartography cube. And this is technically from Mick Aitkin, I don't know how to pronounce that, 1994, volume 6, I guess, but displayed on next slide in Dodge 2015. And this is the series of steps that you go through in geographical research. Explore is the first step. You start by answering basic questions, such as what is going on here type questions. And for Bachmann and Kaiser, that was giving the assessments to the students for data collection before performing any analysis. And by also doing their own research of the previous literature and, asking questions about web-based mapping, which is probably what I should have put there. Um, and looking at previous studies and seeing what has been done previously, and then giving the students the and collecting the data. Analysis, using interactive maps to identify and assess complex data, breaking it down in the hopes of revealing any patterns that couldn't be found in raw data. So they didn't use maps to break it down because they're using web maps, but they used the statistical maps, the PCAs, the bivariate analysis, and the focus group analysis. Um, and that would be found so that would be the analysis part of the cartography cube. The synthesis part would be the assemblage of the evidence to support hypotheses, which can sometimes contain discussions amongst a team of research around the screen. Bachmann and Kaiser analyzed all their data and were able to confirm both of their hypotheses, so that is their synthesis. And present, usually a competent component towards the end of a research project is to present to an external audience. And Bachmann and Kaiser, I don't know if they did present their work, but they published their work. So for me, that is that's that part of the cube. The present cube for them was to publish the study. So that is how I believe the cartography cube elucidates the Bachmann and Kaiser study. And here is the cartography cube, starting off with explore, then you go to analysis, synthesis, and present. And then here's the reference page, and we are done at 37 minutes. Wow. Okay. That is it for me. All right, we'll see how many points I lose for going over by 20 minutes. Hopefully not too many. Worked really hard on this. Take care, folks.